JJ here. Welcome back to our video series on deephaven.learn. In the previous installment, I covered some considerations to keep in mind when developing applications for static data. This time around, I want to mention a couple considerations for making the transition from static to real-time data. In this deephaven session, I have two scripts that I'll run through to show what the data looks like as the shape, size, and real-time nature of my tables change. In this first example, I create a table with one row and one column. I've defined my gather function to return a two-dimensional NumPy array of 32-bit integers. When I run this code, my model function prints out the array with a singular value. Pretty simple stuff. The output array in this case, despite containing only one value, is still two-dimensional. Let's say I want to add a second column. I'll call it y, and I'll make it equal to 2 times the current row index. Additionally, when I use the learn function call, I need to add y to my list of accepted columns. When I run this code, we'll see 2 sets of square brackets around the output data. This means that the NumPy array is still two-dimensional despite having only one row. I can remove the second dimension using NumPy's squeeze method if I'd like, and if that's how I need to pass the data into my model. Instead of a second column, let's add a second row. This time, I'll have one column with 2 rows. Want to guess what I get from my gather function? If you guess a two-dimensional column vector, you're right. No matter how many rows and columns I specify, I always get a two-dimensional NumPy array out on the other side. This is an important concept for both static and real-time data. In real-time applications, I'll get two-dimensional data to work with. But how much of it will I get, and how often will I get it? This is an important question to consider. Let's find out how much I get by testing it out. The script will write 10 rows of 3 columns of random numbers between 0 and 1. They're written at a rate of n per second, where I'll change the value of n and see what happens. In this case, I use the variable write rate in place of n. Let's start with 1 row per second. With 1 per second, my model function prints a two-dimensional row vector every second to the console window. Let's now change the write rate to 2. This time around, we see the same output, but each print happens a half a second after the previous one. If we change n to 100, we'll see the same thing, but each row looks like it's being printed at nearly the same time. deephaven.learn utilizes deephaven's table update model, which means that you'll see new incoming data as soon as it's received. In this example, I write only 1 row at a time. However, if I were to write 2 rows at once, we would see that reflected in the print statements. In this video, I cover the transfer of data between deephaven tables and NumPy arrays in both static and real-time contexts. We saw that the data looks very similar in both, but in real-time applications, you'll receive new data as soon as it shows up in a table. deephaven.learn was designed to work with both static and real-time data, and to make the transition from static to real-time applications a simple one. Thank you for watching this video. Like the video and subscribe to the channel for more content like this. I'll see you next time, where I'll make a deeper dive into real-time applications by showing an example of one.